Welcome to the third Complexity Vidcast. I'm Molly Fortnow, here with Lance Fortnow and Bill Gassarch. Let's get started. Do. Hello.
Hello. Hi, I'm Lance.
I'm Bill.
And our host today is Molly Fortnow.
That's me.
And Molly's going to ask us questions about computer science and complexity, everything she wanted to know.
Okay, what exactly is computer science and complexity?
That's two questions. What's computer science? What's complexity?
I'll take computer science.
For 10.
Computer science is the study of process, computation, how things compute, and the best way to do it.
Okay, and I'll go with complexity theory is, given a problem, we want to know how complex it is. In particular, we want limits on what we can or can't do, but more generally, we want to study what can we do with computation. Now, algorithms is optimistic. Hey, we can do X, Y, and Z. Our field is perhaps pessimistic, complexity theory. Gee, we can't do X, Y, and Z. Would you add to that, probably?
I think the goal is to try to understand what efficient computation is.
Yeah.
And so what we can do efficiently and what we can't do efficiently, and the different notions of efficient.
Okay, so how would you define efficient?
Oh.
That's a good question. Typically, we define efficient to be you run in a reasonable amount of time compared to the program size, the size of your problem you're trying to solve. So we have some formal notions like polynomial time, but basically it just should run in a reasonable amount of time.
Yeah, one difference is that as theorists, we would say things like polytime or n squared or n log n, whereas in the real world they might say 18 minutes or 1 minute or 30 seconds, depending on what the application actually is.
Okay, so how does computational complexity relate to daily life?
Well, gone for the jugular, boy.
Well, I think every day you have choices to make and you have problems you need to solve. You might have to say, oh, today I've got to go to school and after school I've got to go to the library, I've got to go to the bookstore, I've got to go to Starbucks, I've got to go meet my friend, and then you're wondering, how can I do all that? I only have like 2 hours, and you're saying, well, what order can I do things in? And it might be very hard to figure out what the best order is. And that's kind of a computational problem that we look at.
And I'll add to that actually, that just today, about an hour ago, you were packing for the trip. And so you were solving a packing problem. You used the algorithm called, I forgot so-and-so. I forgot so-and-so.
I also use the algorithm of, this doesn't fit, I'll stick it in Bill's luggage.
That helps too, yes.
So, if you are using this computational complexity in daily life, then
Yes, then what?
then why do you think it's important for people to know about it?
Because I think it's important for us to understand the best, most efficient ways to do things.
And also, depending on people, should every single person on the planet read our blog and know what complexity is? Yes.
I agree.
Well, okay then. Are you upset that every single person on the planet doesn't read your blog?
Oh wait, I did.
They don't? Really? Let us live in our delusional world. Next question.
Wait a second, I don't.
Your own daughter does not read your blog? Gosh.
Follows me on Twitter, though.
Yeah, I follow you on Twitter. You don't follow me on Twitter.
All his tweets were taking up all my space.
Next question, please.
If you could, talk to anyone about computational complexity, who would it be?
Living or dead?
Living or dead?
Oh, wow. Looking for dead. Wow. Okay, Lance, go first.
Except for it might be for you to chat with the zombies, just saying.
Living, dead, or undead. Okay.
I guess if I were going to talk to complexity, I would want to actually go talk to someone like someone who hadn't even thought of the idea, someone like Ben Franklin.
Wow. Oh, and what would you tell him?
I would tell him, someday computation is going to matter.
And what do you think he'd say to that?
He would say, "Phooey, now it's on my iPhone." Really impressive.
Okay, if I could talk to anyone in the world, living or dead or undead, about complexity theory, it would be Lance Fortnow. But one day.
Yes, I would like to talk to Lance Fortnow too.
Why? Is Lance Fortnow really that famous?
No, not really.
Okay, I'll give a serious answer. I was thinking more of current people, but the weird thing is, who I want to talk to currently, I can email them. It's not really a fantasy. I would love to talk to Avi Wigderson or Terry Tao or Gowers or Yao about complexity or Luca, but I can't.
But you don't.
Well, I probably should. So I think yours is more interesting than sort of the past. I go for the more recent past. I think von Neumann. Because von Neumann was sort of on the edge. He was doing computer science, but not in the modern sense of the world. So I think he would understand where we're coming from.
Okay. But how about Turing?
Oh, that's good too. Yeah, Turing also good. In fact, Turing didn't really see the problem of scale the way we see it now. So I think it'd be good to tell him, Turing, you can't just build a machine that actually does everything, or you can, but there are engineering issues there that you can't ignore.
Well, I hope they don't want to discourage him.
That's the point. Okay.
If you could, this is kind of off the subject, but if you could tell anyone who didn't live in the time of computers what Google was, what do you think they would say?
It's magic! Burn him! He's a warlock! Ah!
Basically, I would say, I have a device in my pocket that can answer any question, tell me exactly where I am, predict the weather, and communicate with anyone in the world and be instantaneously. And they would be like, that's just incredible.
That is really incredible. I want to remind you that in days of yore, in old days, a knight would go off and fight a battle, and he could not find his way home and would die.
Yes.
They didn't have MapQuest back then.
Or GPS.
Or iPhones.
Or iPhones, right.
Yeah, the Dark Ages, literally. Okay. No, seriously, if Lance is right, though, they would be amazed. It might be hard to even communicate with them.
It would be like telling them that time travel exists.
Well, of course it does, because how would I talk to these people otherwise?
Exactly.
All right.
Okay, unless you wanted to talk to zombies.
Okay.
So, let me think.
Okay, last question, because we only have 10 minutes.
Yeah, and there are only 3 minutes left. So, if you could discover anything that is undiscovered about computational complexity or computer science, what would you discover?
This is an easy one.
Yeah. Okay. Well,
Let's say it together. 1, 2, 3. P not equal to NP.
Is that the one that got featured in the magazine or whatever?
Yeah, that's right.
And the New York Times, by the way?
Yeah, that's right. Thanks for the plug.
Yeah, you're famous. Okay.
Lance is the master of print and video media.
Okay, now if you wanted to ask me one question about computer science that you think I know, what would you ask me?
I would ask you about, how does Google work? Do you know?
Well, it searches all the websites with the words that you've looked up, and it shows you all the websites that are most relevant to the words you looked up.
Do you know how it figures out what's most relevant?
The ones that use those words most.
No, not quite.
What?
The ones that get pointed to a lot.
So it's kind of circular. It works. A website is important if people think it's important.
Oh, interesting. Well, that's all the time we have for today. This is Molly Fortnow,
Wait,
signing off.
Say the sign-off phrase.
What's the sign-off phrase?
In a complex world, best to keep it simple.
In a complex world, it's best to keep it simple. Molly Fortnow.
And Lance Fortnow.
And Bill Sarge.
Signing off.